Mathematics and Physics Part 12. Today we are going to learn about applications of derivatives, that is differentiation as a rate measure. Rate is always time with respect to time how that quantity is changing. Here if you take this one, dy by dx is a differentiation of y with respect to x. How y value changing with respect to x. So we can call it as rate of change of y with respect to the x value. That means x is changing here, with the x y value is also changing. So for this there is a rule of relationship between y and x. Depending on that one we can find out if suppose y is equal to x cube. So how y changes with respect to x? We know this is 3x square. So change in y is equal to 3x square times of change in x. This is a change of y with respect to x. Now, in this case, now suppose if you write velocity that we studied in high school, 9th class, 8th class. Velocity we have studied. This is a displacement by time. Displacement by time. Suppose if a body travels from A to point B, the total displacement, let us say x, and the total time taken is t, and the particular body has moved along the straight line. So what is the velocity between A and B? So we can write velocity can be written as x by t. In this, students, suppose if you take a small displacement, only delta x between C and D, and the corresponding time will be delta t, then velocity can also be written as delta x by delta t. Or suppose if you take a minute portion, very small portion here, only this much, this we denote with dx, very infinitely small change in displacement, by the corresponding time dt. This is possible when limit of delta t tends to 0, then delta x by delta t can be written as dx by dt. This is also velocity. So here velocity is total distance by total time. Here velocity is small distance by small time. Here velocity very finite displacement by corresponding finite infinitely small time interval. So in all these cases we will use velocity as dx by dt. So what is the meaning of this one? How the value of x is changing, how the value of x is changing with respect to the time, how the value of x is changing. So this is called velocity. So this is also at the rate, at what rate x is changing, at what rate means time here, at what rate x is changing, that we call it as velocity. So now we can write velocity as v is equal, instead of displacement by time, the very finite displacement by the corresponding time, we can write it as dx by dt, the small x dx by dt. So velocity can be written as dx by dt, instead of writing everything, this one. So now we can remove this displacement and time, then we will get only this dx by dt. So velocity is dx by dt. Now I am going to write this as velocity v is equal to dx by dt. The rate at which x is changing is called velocity. But what is this velocity? Now we can write this the same thing. What is velocity? The rate of change in displacement with respect to time is called rate of change of displacement with respect to time is called velocity. Similarly, if you take the acceleration A is given by change in velocity by time or derivative of velocity with respect to time or rate of change in velocity with respect to time. Similarly, we can write a force which can be written as F is equal to dP by dt. Here P is momentum. So this is the derivative of momentum with respect to time. Force can be written as derivative of momentum with respect to time is called force. Next one, torque can be written as tau is equal to dL by dt. This is the rate of change of angular momentum is called torque. So this is a derivative of angular momentum with respect to time is called torque. Similarly, if you write one more, power can be written as dW by dt. Rate of doing work is called power. Derivative of work with respect to time. Derivative of work with respect to time. Definitions of differentiation. Here, the area of a circle is given by A is equal to pi d square by 4, where d is the diameter of the circle. How fast the area changing with respect to the diameter? When the diameter is 10 meter. So the diameter given in this problem is 10 meter. They are asking us to find out how fast the area is changing. Change in area, small change in area with respect to diameter d we are writing. So this is a change in area with respect to diameter. First of all, students, the given formula, the relation between area and diameter of a circle is given by A is equal to pi d square by 4. So we are differentiating A with respect to d. So what I am going to write here is d by dA dd of A. That means I am differentiating A with respect to diameter. On right side also I am going to write d by dd of, that right side we have pi d square by 4. We want this dA by dt and we need dA by dt only. So we are going to write dA by dd is given by differentiation of A with respect to d is given by. In this you can see, students, pi is a constant, 4 is a constant. So bring both 4 pi and 4 outside. The remaining terms are d by dd of d square. This is just like d by dx of x square. So power will be reduced by 1 and multiply the same power, then we will get dA by dd on left side is given by pi by 4 on right side. This d square will become 2d. 2 ones, 2 2's. So the answer is pi d by 2. So this is the relation between the rate at which area changing with diameter is pi d by 2. But in the question, how fast area is changing when diameter is 10 meter? So we can write this is d a by dd is equal pi by 2 into what is capital D? In the diagram, in the question itself we have given 10. So answer is 5D. 5 pi. 5 pi. So I'm writing 5 pi. This is a change in area by diameter. Area is measured in meter square. Diameter measured in meter. So the answer is 5 pi meters. Now we will see the next problem. According to Boyle's law, the pressure of a given mass of gas is proportional to its volume, and remember it is true only if the temperature is constant. Find the rate of change of pressure with respect to volume. Students, Boyle's law states that according to Boyle's law, the pressure of a gas inversely proportional to its volume. Pressure denoted with the letter P and volume denoted with the letter V. So this can be written as pressure is equal to constant C by V. So this is our relation between PV. But what we need change of pressure with respect to volume. So we can write this as change in pressure, that is D in pressure by D in this volume. So pressure variation with respect to volume. So we need this value. To find out dP by dV, here we have P, the same expression can be written as PV is also constant. So this is UV formula. From this, if you write this equation, if you differentiate this equation here, I am differentiating this equation, differentiate with respect to volume, this expression can be written as d by dV of P. I am differentiating left side with respect to volume, that is what I want, dP by dV. Right side also we have to differentiate with respect to volume only. Now we need dP by dV. This is dP by dV is equal. We know this is constant, so bring the constant outside. The remaining terms d by dV are 1 by V. From this, we need this dP by dV, that is change in pressure with respect to volume. This can be written as dP by dV is equal constant into d by dV of this V 1 by V power 1 when goes up to become V power minus 1. From this, dP by dV, this is constant C. Now, power will be reduced by 1 because this is the form of d by dx of x power n. Our power rule, this will become V power minus 1 multiply with minus 1. You will get dP by dV is equal to C into V power minus 2 into minus 1. So our final target is finding dP by dV, which is equal to minus C by V square. So this is the answer for this question. The rate at which power is changing with respect to the volume. Now, third problem. Find the average rate of change of area with respect to its radius. As the radius is changing from, they have given three different problems. First A, radius changing from 2 to 3 in the first case. Now first area of the circle is given by pi r square. It is given a circle, area pi r square. We are finding change in area with respect to radius. This is also, this is dA by dr. This is also dA by dr of pi r square. So dA by dr is equal, pi is constant, r square is 2r. So this will become 2 pi r. So this is the formula that we are going to use to solve this problem. So the rate at which area changing with the radius is 2 pi r. Now first case, we are writing dA by dr is equal 2 pi. What is this r? Initially r is 2 and then it is 3. They are asking us to find out the average rate. So I have to take the average value of these two, which is 2 plus 3 by 2, which is equal to 2.5. So I will take that to 2.5. Answer is 5 pi. This is the answer for the first problem. Now second one, students. When the radius changes from 2.5 to 3, first of all we will write the average radius, which is equal to 2.75. Average of these two is 2.75. So dA by dr is equal to 2 pi into 2.75. This is 5.5 pi. Third one. The average value from 2 to 2.5 here, when the radius changes from 2 to 2.1, the average value of this one is 2.05. Then dA by dr can be written as 2 pi into 2.05. If you multiply this to 4.1 pi is the answer for this one. Rate measure. Another topic is maxima minima, which is very important for physics students. Students, when a function is given such that y depends on x, as shown in the figure. So here it is not a linear relation. First its value increasing and then decreasing, becoming very small and then increasing. So y is changing with respect to x with this. Now in this one, if you take this point and if you take another point here, at P, at the first point P and Q, here y has maximum value, here y has minimum value. So if you take this diagram, in this diagram, you can see, in this diagram, if you take the slope of this one, here we want to find out slope of this curve. Here this is the slope, and if you draw a line here, this is the slope, and then if you take, this is the slope at this point. Similarly here, the slope is decreasing. Here, the slope is 0. At the maxima, this point is called maxima, slope is 0. That means it is not making any value or any slope at this point. This is parallel to x-axis. So this point, maxima point, let me take this as P. Let us say this is Q. So at P, so it is a maximum y. So this is the corresponding maximum. Before this, here slope is alpha, this is beta, and gamma is 0 because slope is the angle between two lines. So first one is always x-axis. Second line is our line. This is the first one. Here we want to find out this angle. This is alpha. At this point beta. At this point both lines are parallel. Gamma is equal to 0. And after that, suppose if you want to find out a slope here, draw a line and x-axis. So this angle increasing, and here draw a line and this one tangent. So this theta is increasing, theta 1, theta 2. And if you observe this one, students, as we move from this point to this point, from here to here, we have different points at point 1, point 2, point 3, point 4, point 5. From here to here, slope of this curve with x-axis is decreasing and becoming 0. So at the maxima, we are writing slope of curve is 0. Slope of curve is 0. Students, we know, we have studied this. Slope of a curve is nothing but dy by dx. How y is changing with respect to x? So slope is nothing but dy by dx is equal to 0. So for this curve, at the maxima, slope is 0 or dy by dx is 0. But if you observe these points from here to here to here to here, here, as you move from each point, the angle made by this tangent with the x-axis is decreasing. Now it is decreasing and becoming 0 here and then increasing. So slope, that is dy by dx, first decreasing and becoming 0 and becomes 0 at maxima. Becomes 0 at maxima. At maxima, slope of this curve will be 0. So from here to here, first left of this maxima, slope is decreasing. So rate of change of slope, that is nothing but rate at which dy by dx is changing. So we are going to write d by dx of slope, that is dy by dx. This is nothing but double derivative of y, which we can write d square y by dx square. The slope is decreasing. So as it is decreasing, this is negative. Decreasing slope is rate of change of slope is negative. This is less than 0. So please remember, students, at the maxima, first condition is dy by dx is 0. Second condition, d square y by dx square is less than 0. So for maximum condition is slope must be 0 and rate of change of slope must be negative. Now if you take this point, student, the other point, minima point, here we can see, when finding the slope here at this point, draw a tangent, draw a line parallel to x-axis. This is theta 1, and then if you want to find out angle here, this is theta 2, and now this is theta. Here, if you observe this one, the angle made by this one with the x-axis at minima is 0. Once again I am writing at minima, slope of curve is 0. Slope of curve is 0. And you can see slope of curve is 0 for maximum and the slope of curve is 0 at minima. And from this diagram, it is clear that here if you take this portion, a small portion of the curve, even here if you take a small portion of curve, and these two portions are parallel to x-axis. So here slope is 0. Here slope is 0. Maxima or minima value of the functions given. First we will take the first equation. Y is equal 25x square minus 10x plus 5. To find out maxima or minima, first of all we need to find out change of y with respect to x, that is dy by dx. dy by dx is, this is 25, x square derivative is 2x. So this is 50x minus 10 into 1 and derivative of 5 is 0. So students, dy by dx will become 50x minus 10. So this is a dy by dx of this one. We know that whether it is maxima or minima, dy by dx must be equal to 0. So by taking 50x minus 10 is equal to 0, 50x is equal to 10, x is equal to 10 by 50 or 1 by 5. So now when x is equal to 1 by 5, the given function is either maxima or minima. First, how to find out that condition for maxima or minima? For that, we need to find out second derivative of y, d square y by dx square. This is nothing but d by dx of, this is dy by dx. This is 50x minus 10. So d square y by dx square is equal 50x is 50 and x derivative is 1 and 10 derivative will become 0. So d square y by dx square is equal plus 50. Students, when d square y by dx square is greater than 0, so this is greater than 0, y has minimum value. Y has minimum value. So what is that minimum value? To find out that minimum value, so y minimum, we are finding y minimum. Y is 25 x square minus 10x plus 5. So minimum value of y is 1 by 25. What is the x value? 1 by 5. So we are writing 1 by 5 whole square minus 10 into 1 by 5 plus 5. This is 25. 1 by 25. 10 by 5 plus 5. 25 will cancel. 1 minus 2 plus 5. 5 plus 1, 6 minus 2. So the minimum value of y for this given function is 4. So y has minimum value and its minimum value is 4. Now second one, y is equal to 9 minus x minus 3 whole square. Y is equal to 9 minus x minus 3 whole square. Now we need to find out the maxima or minimum value of this function. So first of all, let me expand this equation a minus b whole square, x square plus y, that is a square plus b square means a square plus b square minus 2ab minus 6x. So the given function can written as 9 minus x square minus 9 plus 6x. Now you can see these two get cancelled. This will become y is equal to 6x minus x square. Now this is the function that we obtained now. Now we will write dy by dx. To check the maximum value, to find out, first of all, we made to this dy by dx equal to 0. That is dy by dx of 6x minus x square. This is 6x1 minus 2x. So dy by dx is equal to 6 minus 2x. Now, if it is 0, students, our value will become 6 minus 2x is equal to 0. 6 is equal to 2x. X is equal to 6 by 2. This is 3. So, at x is equal to 3, the function will have either maxima or minimum value. But we will have to check it whether it is maxima or minima. For that, the second condition is d square y by dx square. If it is less than 0, this is minimum. D square y by dx square greater than 0. Sorry, this is minimum and this is maximum. So now we are checking this. D square y by dx square, that is d by dx of 6 minus 2x, because this is dy by dx. Now differentiate this one. D square y by dx square is equal, derivative of 6 is 0 and derivative of 2 is 2 into 1. So d square y by dx square is equal to minus 2, and it is clearly less than 0. When it is less than 0, the function will have maximum value. So here y has a maximum value for this value x is equal to 3. So what is that y max, which is given by 9 minus x minus 3 whole square. When x is equal to 3, we can write 9 minus 3 minus 3 whole square. This will become 0. So y maximum value is equal to 9.